Hey people, what's a traffic advisor? Some of you might be asking. Well, this little device here is the type of thing that's used to control the lights on like emergency vehicles or like roadwork vehicles and things like that. It's the lights that you see that are kind of like cycling, like either left or like right or, like spreading out from the middle or whatever, just flashing. And that's to like, tell cars to go around to the right, to the left, etc. I'm sure anybody that's been on the road has seen something like that. So this is, yeah, the type of thing that would control something like that. Now, this one here was given to me by a friend. I actually don't even know if it works or not. It's not really something I need to like fix or anything like that. But I thought we'd take a look at it today, see what's inside, and we'll do a little test here and see if it actually works. As you can see, I've got some LEDs up here and a bunch of resistors. And then I've got this strip of wire going to the back here where the lamps would normally connect. And then we've got 3 wires here. One's going to be for power, one's ground, and then one's apparently for, I'm guessing it's got a backlight maybe to like light all this stuff up or something. And this here, I don't have the proper connector, so I've kind of just like stuck those pins into, and some of these are coming out where I think they should go. So hopefully if those stay in there, they'll make good enough contact to see if this thing works. The only other things I've got here is 8 LEDs. I've got all these resistors here. They're all 1K resistors, just providing current limiting to the LEDs because it's not like I was going to get a bunch of incandescent bulbs or anything like that to hook to this thing. And the connector just came out. All right, I'll have to redo that. But anyways, well, since that came off. So on the back here, we see we've got this. It's a 12-pin connector, but it's only got 10 of the pins actually populated. So all 8 lamps can hook up to like this connector back here. There's one that provides 12 volts, and then there's one that does like remote control, I guess, and everything is like down here at the bottom. It just doesn't give a pin out of the actual like lamp connections here, but I looked it up online, so I'm pretty sure what it's doing is it's just basically switching ground to like the outputs. So those are probably going to be all controlled by like some little transistors or MOSFETs in there. It's got another connector over here. It says that's an auxiliary connector, so I don't know if that's to like go off to like another device, or another device can control this one or something like that. There's different settings, and those are controlled by the dip switches that we can see like right back here. We'll get a closer look at this here in a minute, but it's just kind of like a little overview. Got a little 15 amp fuse right there. And then I think to open this up, we've got 4 screws up here in the front that I think we'll just have to remove. Maybe this whole thing like here will slide out. On the front, we've got low and high. I'm guessing that controls the current to the outputs. I guess we'll see how that happens. I don't know if we're going to be able to notice that here on these LEDs. So yeah, low, high. This here selects the type of pattern. So we've got like a left going pattern. We've got a right going pattern, a split. And then I guess the flash is just going to flash all of them on and off. And I guess this here is going to basically indicate what's happening on the actual like output. And this one here is not labeled, but I'm assuming that that's to turn it like the output on and off. So yeah, not sure, but I guess we'll see. So let's get this hooked back up. We'll hook it up to the power supply, and we'll see what it does. Okay, I've got everything reconnected. I don't know if I've got these LEDs hooked up in the right pins here to, indicate whatever it shows on here. So I'm going to plug this into the power supply now. This is 12 volts. And shouldn't have anything because this is off, and this one here is off as well. So let's see what happens. Let's just go ahead and do high and turn that on. That doesn't seem to be working. Let's try plugging this one in. This is I think I said it was backlight to 12 volts. Okay, so that comes on. You see we got high, off, and there. Yeah, so I guess it's not working. What happens if we flip this switch here? Oh, I guess I should have set up those dip switches in the back for 8 lamps. Alright, so the dip switches in the back seem to be configured properly. I'm still not getting any output. The only thing I can think of is that maybe it could be switching the positive output to the lights, and so I need to have everything grounded. Like all the LEDs grounded, and then it's controlling the positive. So I'm going to have to flip all the LEDs around and hook up the common here to ground instead. So let's see if that works. No, I guess something's wrong with it because this one here is just like permanently on. Switching this here doesn't seem to do anything, but I think I would still get like at least an indicator here, even if this wasn't wired properly. All right, well, that doesn't seem to be working, so let's just go ahead and open it up and see what's inside. Okay, so we got 4 T10 Torx screws that we're just going to remove, and hopefully that'll give us some access. All right, everything feels like it's starting to get loose here, so I think that should do it. So this little bezel comes off with the front there, and this, okay, so this just slides forward, so this case just goes back like that, and that's the aluminum casing there. Nothing crazy going on there. And here is the insides. So yeah, sure enough, looks like it's a bunch of I can't tell if they're transistors or MOSFETs yet. We've got a little PIC micro down there running the show. Got this multi-selector like wafer switch looking here. Everything's got plugs going into the board, so it should be easy to remove without having to unsolder anything. Okay, so this here looks like it's for this connector. So that has nothing to do with the output. It's just this, I guess, and then this switch over here. But as we saw, we were getting absolutely nothing. So I wonder if this microcontroller is like somehow bricked or something. Or maybe there's like a bad voltage regulator or something on the board. So yeah, let's remove that board from in there and see what's all going on in there. This plug should just be able to pull up. And then I can push on these right here. All right, so that's coming out. That gives us some area there to work with. These can come off as well. Might be better off just squeezing it with the plier, though. There we go. And that can just unplug from there. Looks like if we just remove this connector right here, I don't have to deal with removing that switch. And then I'm assuming that that has a little grub screw in there, so I have to, oh, and right there too, it's got 2, so got to undo those. This knob will come out, and then there's probably going to be a nut on here holding on this switch. But it's also got this sheet here, like stuck to the aluminum. That's probably not going to allow that to come up. Unless it can, like, tilt out, maybe. Well, let's see. Let's go ahead and remove this fuse. All right, those are loose, so now this knob can come off. And there's the nut. Okay, loosen that up. Get this one out of here. All right. Now that can come out. And this is going to stop me, isn't it? Okay. Now that can come off. There we go. Now that switches out. 2 screws holding the board to the case, and I think we're free. All right, so it's going to come out. This switch right here is kind of making things a little difficult. All right, let's just bend this out a little bit. There it goes. Sweet. All right, so there's the board. Anything underneath? Nope. That looks like it was touched up at some point, probably when it was built, because this doesn't look like it's been out otherwise. You can see how there's like a lot of copper right there to provide heat sinking for those components that we'll take a look at here in a second. We'll see what they are. Pull out the microscope and we'll take a look at some of this stuff up close and we'll see what kind of PIC that is. So there's that row of LEDs. That would be the indicators up in the front that not doing anything. That there's an LM317, so that's going to be the voltage regulator. And so it's possible that maybe there's a problem with that, and that's why it's not working, because there's like no corrosion or anything on this board. At least none that I can see. Yeah, everything looks pretty clean, so not sure why it's not working. Well, I gotta admit, people, I thought that this was going to be like fairly boring inside and there's not going to be anything all that interesting. However, things took a suddenly an interesting turn. And these MOSFETs here, they are made by On Semiconductor. They are NCV 8401A. And just on a quick glance here, looking at it, it doesn't really appear to be anything like all that exciting or interesting. We see that that the drain is just soldered to this big copper pad here, and that's used for like heat sinking. We've got our source pin, we've got our gate pin that goes to resistor. So you'd think that it'd be just like a regular old MOSFET there, just turning the lights on and off. However, if we look at the data sheet, this here is a self-protected low side driver with temperature and current limit. This low side basically just meaning that it's like an N-channel type MOSFET. So this thing inside has a built-in protection, and it even says right here, this device offers protection and is suitable for harsh automotive environments. So no surprise that it's we found it inside of an automotive product. But check this out. That's what's inside of this MOSFET. So it's got current sense, current limits, and it's got a temperature limit, as well as over voltage protection. And if we look right here, it's clamped to 42 volts. So that would be like probably this set of diodes right there. This here is just like the freewheeling diode that's built in. And it's current limited to 33 amps. And of course, it says that it may be limited below this value depending on the input conditions. So definitely a lot more interesting than I was expecting. And right here we see that it's got short circuit protection, thermal shutdown with automatic restart, over voltage protection, the integrated clamp for inductive switching, ESD protection, and it's also logic level input capable. And then down here we see that typical applications, automotive and industrial. So yeah, no surprises there. Now, I myself have never seen a MOSFET that had like this much stuff inside. Usually, you know, you're just like seeing like this thing right here with just the MOSFET and maybe the clamping diode, but that's about it. But this one, when I saw this little diagram, I was like, holy crap. So yeah, that caught me by surprise. And then the microcontroller, that's a microchip device. It's PIC 16F87887. It looks like it's got something else, laser etch here at the top. I don't know if maybe that's like the company that built this device, laser etched it right there. But interesting thing that I noticed here is that they are using pretty much all of the ports on this microcontroller to drive different things. So like, for example, it looks like whatever port this is on this side is driving all the MOSFETs. This port over here is driving all the LEDs right here in the front for the indicator. And then we've got another port here going to the switch or the dip switches in the back for the different options that you can select. So instead of using like a smaller microcontroller with a lower pin count and then maybe using some like shift registers, latches or something, they're using, they paid for every port, they're using every port. Now, interestingly, this PIC Micro on Microchip's own website, it says right here, recommended for automotive design. And this is the data sheet for it. I mean, it's a really long document, not like we're going to go through it or anything. But yeah, it's got quite a bit of stuff built in. And it's not even like the lowest type here. It looks like it's like the one with the most features of this family. So it looks like it's got 8K of flash, 368 bytes of RAM, 256 bytes of EEPROM. And so, yeah, 14 channels of 10-bit analog to digital. It's quite feature-packed for just flashing lights. Looks like we've got a little in-circuit programming port right here off to the side. I have already verified that these pins go to the programming pins, which are usually on port B on these PIC Micros. So those do go to port B. I got a couple little test points right there. These are actually really nice little test points. So it looks like that might be, I'm not sure if this is for power pin. No, I think that was one of the data pins. Other stuff around the board, we see a lot of passives there, little tantalum caps. That's the switch for selecting high and low. Not sure exactly if this has anything to do with the microcontroller or if it's just some sort of other power thing going on here, because we see we got one pin coming out here, looks like. I can't really tell where it goes. It's really hard to tell on this black solder mask. It looks like it goes underneath the diode. Snakes around this way, I think, or maybe not. I don't know. I can't tell. But there are a lot of diodes over on this side. No idea what those are all doing. There's the voltage regulator, so maybe we could check and see if the voltage coming out of this is fine, and maybe that's the reason why this thing isn't working. Although, like I said, it's possible that, maybe this chip is dead for some reason. But, I mean, there's really not a whole lot in here. So, if anything, it'd probably either be a power issue where the voltage regulator isn't working, or there could be something else wrong here, but nothing looks burnt. So, like I said, I don't know. And then we've got a big diode here for reverse polarity protection. So that goes straight into the positive coming out of the fuse. This pin here for the fuse is the one that goes directly to the battery input. The other pin was the one that goes to lighting up the backlights inside. So that would be like these LEDs right here. That's one of them. There's another one there. And then there's another one right here. So yeah, let's apply power with this thing open. We'll probe around and see what we got. All right, people. I'm not even kidding. This is my 5th take trying to record this board. And the first 4 takes, the first one, I forgot to turn my microphone on. The second take, I forgot to turn the switch here on so we could probe around on the board. The third take, I realized that I didn't even have the fuse installed. So the first 2 takes wouldn't have been worth anything anyway. The 4th take, I realized I didn't plug power into the board. So 5th take, I've got the fuse installed. We're going to switch this on, and I'm going to make sure that I hooked up the power supply input. So here we go. So I've got everything here minimally connected. I have 12 volts coming into this pin as well as the backlight pin. And then the negative obviously goes to ground. We're going to switch this to the high position. And we are going to test between this test point 2 right here. This is a ground point. And the positive of this capacitor, that should be a positive going into this microcontroller. So if there's nothing there, then we know that there's probably something wrong on this side of the board and that this microcontroller is not getting any power. And if we are getting power, then it probably means that there's something wrong with the microcontroller. So let's see what happens. First of all, I'm going to apply 12 volts to the board. And we see that the backlights come on. And these LEDs, they're like a really nice green in my opinion. I actually kind of like those. And let's go ahead and turn the switch to high. And everything is connected. And I'm recording audio. So, okay, here we go. So I'm going to hook up ground here. Let's see what we're getting at this capacitor. And nothing. It's absolutely dead. So let's see. Let's switch this to a low now. See if that makes any difference. There's still nothing at that pin right there. Let's see across the capacitor itself. Yeah. No, there's nothing there. Okay. This here is an LM317 voltage regulator. If this is pinned out the same way as a TO220, this should be the adjustment pin. The tab should be the output, and this other pin over here should be the input. So I'm going to take the meter probe, and I'm going to hook that up to the ground over here. Just going to stick that in there. Let's see if we are getting anything at the voltage input pin. I'm going to put this back on high, kind of move it off to the side there. So let's see what happens at this pin. Is there any voltage at this pin? There is absolutely nothing at that pin. Wiggling this around doesn't seem to do anything. See, I'm low. Nothing. Let's see what we're getting at this switch over here. Nothing there. Hey, that has something. What about this here? This should have 12 volts if this switch is working. Nothing there. Wow, could it be that this switch is bad? Because it switched to one side here. If this has 12 volts coming in, then there should be something at one of these 2 pins. And there's nothing. I think this switch is bad. So let's unplug this here. Let's just jump directly across those pins and see if anything happens with these LEDs up in the front. I'm just going to jump them with this right here. See what happens. Hey! It's working! Kind of hard to see what's going on there because they're like everything's so bright, but there we go. Huh, that's so interesting. Yeah, the other side. So it does a lot of different light patterns. As we can see, it's not just like left or right. So the switch here, I think I had it turned all the way clockwise. Let's go ahead and turn it counterclockwise, and that should be left going signal. So 1, 2, 3. All right, so now when I jump these pins here, this should be going towards the left. Let's see what happens. There it goes. Yep, there it is. So absolutely nothing wrong with this device except for the switch being bad. So it probably has like dirty contact or something in there's my guess. There did appear to be some stuff like spilled in the front of it. So, well, since there's nothing else to see here on the board, let's open this up and see what's going on inside. Should be able to pry this up like this. That tab's coming out. Ugh, we see some crusty stuff there already. Oh. Yeah, I'd say that's dirty. Jeez, there's like a lot of... I don't know if it's like old grease or something else got spilled in there. No, something got spilled in there. No idea what it was, but yep, that's definitely the problem. So I guess I could try to clean this out. We can reassemble the thing, and then we can see it working with the LEDs that I set up on that breadboard. And before I actually clean out all this stuff inside, there's a really close-up shot there for all you crust aficionados. We can see that definitely it appeared to be insulating these terminals. There's like a big old flake right there on that one. And then in the middle there, it's just, it looks like it's a combination of grease and whatever got spilled in here. I'm going to guess if this was a part of like an emergency vehicle or something, it was probably coffee. Maybe like coffee with some creamer or something. That's my best guess. I mean, what else could it be? So, yeah, we'll give this all a good cleaning, and I'll reassemble it, and then we can try it out again. The switch is all clean and reassembled now. So if we check continuity between the center and the two outer terminals, we can see that now we actually do have current being conducted. So that's working, and this is working. So I've got power coming into the board here already, and we're only going to use the battery input and the ground. So if I plug this back into here, now we should have this working as soon as we flip the switch. So if we go high, see right there, the LEDs are going in a sequence, and I still have this set to left going. So, and then if we go down here, we go low, this LED turns on. Obviously, we can't tell any difference between these because these are still going to be indicating the same thing. But we should have something different going on at the outputs. So I can hook up those LEDs that I put on the breadboard again. And we should maybe see a difference between the intensity. What I'm thinking this is doing is that when you have the switch here set to low, it's probably using like a low duty cycle to get those external lights to be like a little bit dimmer. But then when you have it set to the high mode, it's probably just, and it didn't want to work there. Oh, I think this was loose. Anyways, when you have it on the high mode, I think it's probably just like fully turning on these MOSFETs so that, you know, they're able to be like a full brightness. But we'll see what happens. So what I'm going to do actually is I'm going to plug this connector back in. That just goes in like that. And I'm going to plug all of these in there, but I'm going to pause this here for a second while I set all that up, and then we'll try it out. I ended up cleaning up the switch a little bit more. The one contact that makes contact when this thing is on the high position was a little bit tarnished still, but once I scraped it and I cleaned it off again, now it's like working every single time. I also made sure that these pins here are making like really good contact, so I could do a little bit of a demo on this thing without having to worry about the LEDs like cutting out or anything. So I played around with it so I could understand like what all these 8 dip switches in the back here did. Counting from the right to the left, we have switch number 1 over here on the right, and we have switch 8 over on the left. And on the bottom of the case, it actually has like a little diagram of like what all the switches do and, you know, what they set, but that's too small to see here. So I'm just going to show this installation document that I found, and it explains, you know, all the switches, same as it does on the bottom. Now it says right here that the default configuration setting is all switches down. And what that does is it sets, well, switch 1 and 2 set the type of light array. It can be from anywhere from 8, 7, 6, or 5. Number 3, 4, and 5, those set the, number 3 sets the traffic advisor bar type. So it can be like a straight bar with, you know, just like a bunch of dash looking things. Or it can be an arrow bar where it has like the 2 little arrows on the ends. Number 4 sets if it's an LED type of bar or if it's halogen. I couldn't really tell what the difference was at first until I actually checked it with the scope. So I'll show you what the difference there is. Switch number 5, that sets this action flash mode or module flash mode. And I'll show you what the difference between those two is as well. Now the last 3 switches is 6, 7, and 8. It sets the type of sequence. So I'll show you, do a little demo of like what that does as well. So yeah, let's go back to the board. And let's go ahead and turn it on to the high position. We've got all the dip switches there to the default down mode. And we can see how right now it's set to like, you know, to go the split mode. So it's just going from the center out. If we go to the go right mode, then it starts from the right, goes to the left. Left mode, obviously it goes to the left. And then the Christmas mode or flash mode, that just like does this pattern here where it's doing like a bunch of I mean, it's not random, but it's like doing a bunch of different like patterns there. So yeah, that's on default. Now, if we go back all the way to the left here and we turn on switch number 1, that should be a 7 light mode. We see that it skips the 1 right there. So now we got these 3 and those 4 going there. So if we flip it to the right mode, we see that it still skips the same LED. It's a split mode. It still just skips that 1 LED right there. And then to flash mode, it basically still does the same patterns. It's just not doing anything with that 1 LED right there. So now let's go to a 6 LED mode. Let's go back to left here. Now we've got 2, 4, and 6. It skips these 2 LEDs right there. So that's on left. That's right. That's split. So we can see it's a little more even because it's got an even number of lights. And if we go to the flash mode, it's just doing its little flash animation there. Now, if we go to a 5 LED mode, let's go all the way back to left. We see that it skips those 2 and that one. And now it's got 2, 3, 4, and 5. So that's left, right. It skips the same LEDs, split. Now it's a little more even because it can have this one like in the center and then so 1, 2, 3 going out. Flash mode. I don't think anything really changes in this pattern. It's just doesn't have those LEDs to flash. But since I have a total of 8 LEDs here, we'll just leave the 2 there at the beginning to 8 mode for the rest of the modes that it's got. Now, so 3, 4, and 5. 3 was which type of bar it is. That one's not going to make a difference in our case because there's like no way I can show you an arrow. Actually, that's not entirely true. I think it did make a difference actually, now that I think about it. So let me show you what that does. So that was switch number 3. Okay, we can see here that this first LED doesn't light up. It only starts from there all the way to the end. So that way it's not going to light it. Like if this was a right pointing arrow, it's not going to light that up. It's only going to light the lines until it gets to the end where there would be another arrow. And if we go right, then we see that it skips the left going arrow and it would light up the right pointing arrow. In split mode, that's, I mean, obviously going to light up everything because it wants you, they want to direct traffic going in like opposite directions or whatever, telling you to avoid the vehicle. Flash mode, that's still the same. That doesn't change anything. So then switch number 4 it selects whether it's an LED or a halogen. And the only way we can see a difference there is if we look at it with the scope. So we'll bring up the scope right there. So right now, since it's, I'm just going to set this one here back to down. Since it's set to down, that means that it's LED. And this only has an effect in the low mode on the switch right here. So I'm going to switch this down to low. And I'm going to probe one of the MOSFETs right here, the gate. I don't want to move this cable here, but I'm like probing down. Oh, you can actually see it. It's right there. So I'm going to probe that one right there. And if we see right there on the top left, you can see the type of, well, it's a little too fast. Let me try to spread it out a little bit there. There you go. You can see the duty cycle there, pulsing the output. Now, if I switch that up, which one, number 4? When it's up, it's going to be halogen mode. We'll see how the pulse there changes. You can see how it gets faster. And you can also notice that these LEDs here got brighter. So watch, I'll put it back down. Look at the LEDs. They get like a tiny little bit dimmer. It might not be as noticeable on camera, but I can tell here in person that it does change. You can kind of tell right there. See, down, up, down. So yeah, that just changes the frequency of the pulse on the low mode. And I mean, that stays the same no matter like what mode you're in. It just changes the speed of the switching. We'll set that back down to 0 or off. So the next 3 switches, 6, 7, and 8, are these settings right here. And if they're all down, it says it's sequence on or off. And that's just what like we see right here. So let's go ahead and switch the first one to, which would be pin number 6, to on or up. So now we see that they all like light up and then they all turn off, all light up, turn off. So that's true for pretty much every mode. Split. Flash is still the same. That doesn't change anything there apparently. So yeah, that was this first one here. We'll return or sequence solid where we had pin switch number 6 on. Now if we turn the two 6 and 8 off and we turn 7 on, that's going to do a 1 lamp sequence. So let's see what that looks like. It's going to be this one right here up. So we see that it's just one LED that goes all the way across, flashes the arrow, or the last one there. If I was to have switch number 3 on over here with an arrow bar, we see that it's going to skip that first one. So that's working as intended. And that's going to, this one LED mode is going to go all the way across like that. For the split, one LED as well. Flash, no change. Now if we've got 6 and 7 up, that's a 2 lamp sequence, as we can see right here. So now we got 2 LEDs going across, and then it just flashes the outer one. So left, right, split, and flash, no change. And then if we have down, down, and up, now that's a 3 lamp sequence, and we see that we can have like 3 LEDs going across there for the left, 3 for the right, and then split. It just does like a total of 3 LEDs that kind of like chase out. So flash again, no change. And then this CA sequence, which would be up, down, and up. Don't remember what that one did. Let's see. So I turn this one on. Okay, how did that differ from the all down mode? Oh, it just seems to be faster. Yeah, so that's left, that's right, split. So is that a difference in the split there? Oops, had that one down. So it just seems to be a little bit faster. That's all I can tell. Yeah, that's all I noticed. I don't know if there's supposed to be anything different going on. Now, the last one I was going to point out here, this is the module flash or the action flash. That's switch number 5. If that is down, that's action flash. which is what's going to happen here if I turn this all the way to flash. So we saw that there it does like a bunch of different like flash modes. But now if we turn that one on, which was number 5, so this one right here, it basically only does like this mode where they're like every other LED's like alternating, and then it gets faster and slower, and then faster and slower, and that's all it does. So it doesn't do like that flash of these like 4 and then these 4, and then it goes into like different modes. It's basically a more of a fixed pattern. It just speeds up or slows down. One last little thing here that I'd kind of forgotten about. There is one more wire or pin on the connector here in the back that I don't actually have going to anything. That's an external connection there for like an external input. If that input has 12 volts going to it, which I can do by plugging this one into that pin, I have 12 volts going into here. This switch is off, so we don't have like high or low mode on. And if we plug that into like a 12 volt source, it immediately triggers this thing to go into a flash mode. So it doesn't matter what the switch up here in the front is set to. It's just going to stick to doing that flash mode. So that's, I guess, if you had like a remote switch somewhere where you wanted to just, turn it on to like warn people, that there's like hazard or whatever, it can just turn that on and the lights just immediately all start flashing. And yeah, I think that's about it. That's all the different operating modes that this thing does. And that's how these dip switches in the back here affect the patterns. So the next time you're out on the road and you see a construction vehicle or an emergency vehicle with these lights going in the back, now you kind of know what's controlling them. I mean, it might not be this exact same unit, but maybe something similar. So yeah, I think that about wraps this one up. I hope it was kind of interesting. I was certainly a bit surprised by finding out that those MOSFETs in there are not like ordinary MOSFETs. Everything else is a little more kind of like not all that crazy. I mean, it's just a linear regulator there, and then we got a PIC microcontroller right there. So, yeah, I think that's going to do it for this one. Thank you all for watching, and I will see you guys around the bench.